I'm going to talk about least common multiples. So you should know what a multiple of a number is. And I'm going to talk about a common multiple between two natural numbers. Specifically the smallest or the least multiple that's common between two of them. All right? So, for example, the number 2 and the number 2, first of all, what are the multiples of 2? Well, you could say 2, 4, 6, 8, 10. Those are all multiples of 2. Now let's do the multiples of 3. Well, you've got 3, 6, 9, 12, 15, etc., etc. Okay. Notice that there are multiples that appear in both lists. Okay. 6 appears in both lists. 12 appears in both lists. And if we extended the list of multiples, we would see more and more numbers that appear in both lists, such as 16. All right? Or excuse me, not 16, but 18. Now, so we have common multiples like 18, like 12, all right? The smallest multiple that's common to both, of course, is the 6, okay? So that's the least common multiple. Let's do another example. So what about if I had, let's say, 10 and 11. So the multiples of 10, you skip count by 10, 10, 20, 30, 40, 50, okay, on and on. And then 11, 11, 22, 33, on and on. It doesn't look like they have anything in common, does it? All right? But if you hang in there, eventually you will get to the number 110. And then when you skip count by 10, you'll also get to 110. And so, lo and behold, they also have a least common multiple. All right? And there'll be other ones if you extended the list further. Okay? Now, you never have to worry that, oh my gosh, what if these two numbers don't have any multiples in common? Okay? The reason you can dispel that fear from your mind is that you can simply multiply the two numbers together. Okay? If you multiply the two numbers together, you'll get a multiple that for each number. All right. In fact, the answer to both of my examples was the product. Okay. The first two numbers I used were 2 and 3. If you multiply those together, then you get 6 for the least common multiple. Or it turns out that way for that example. For 10 and 11, if you multiply those together, then that's 110, which turned out to be the common multiple for that one. Now, that doesn't always work. If you multiply them together, that'll give you a common multiple, but it's not necessarily going to give you the least common multiple. Let me show you an example of that. So, for example, 8 and 4. Okay, the least common multiple of both of those numbers is 8. Okay. However, if you multiplied them together, you would get a much bigger common multiple. Okay? So you can't always rely on simply multiplying them together. So the example with 10 and 11, it was clear that the least common multiple might be very large. All right? You might wonder, what is an easy way, if one exists, to find the least common multiple, especially when you have big numbers. All right? And I'm going to show you such a recipe that will help you when you need to find least common multiples. And they are useful in lots of situations. All right? So let's say we wanted to find the least common multiple of 30 and 12. Okay? Now, I believe it's 120, but let's say we didn't know that. Okay, and let me show you the recipe that will apply if you couldn't see that. All right, so what I would suggest is first write the prime factorization of each. So 20 is 2 squared times 5, and 12 is 2 squared times 3. Okay, now what you want to do now is you want to make a new product of primes that includes each of the prime factorizations. So for example, if I made the product of primes 2 squared times 3 times 5, can you see that that has so the 20, you need 2 2's and a 5 to make the prime factorization of 20. So the blue one has 2 2's and a 5. For the 12, you need 2 2's and a 3. And the blue product has that. So that includes everything. Okay? Now, why would you want to do that? Well, when you create this minimum product that includes both factorizations, that will multiply to the least common multiple. Isn't that cool? So this is, what does this multiply to? 60, it looks like. Ah, see, I was wrong. So I thought 120, but actually 60. So this trick won't fail you even when just multiplying them and guessing that way will. Okay? So this is a very nice trick. Let's do one more example. Okay? All right, so what about if we had the big numbers 112 and 46? Okay, that looks like a job to get the least common multiple of those big numbers, right? Well, okay, we're going to use our trick to make it somewhat easier. So let's see what the prime factorization is for 112. That's let's see, that's 50. 2 times 56, which is 2 times 28, which is 2 times 2 times 4 times 7. So therefore the prime factorization is 2 to the 4 times 7. If I did that correct, let's see. 16 times 7, 16 times 7, 70 and 42. Yes, that is correct. Okay, and then 46, 2 times 23, and I believe 23 is prime. So that's that. All right, so now let's get the smallest product that includes both prime factorizations. So 2 to the 4 times 7 times 23 looks like that's it. Does it have 4 2's and a 7? Yes. Does it have a 2 and a 23? Yes. Okay, so whatever number that blue product multiplies to, that's the least common multiple. Okay, now one important example of where finding the least common multiple is important is in when you're trying to add fractions together that have different denominators. All right, so for example, what is 1/2 plus 1/3? We're not allowed to add fractions right away. We're not allowed to add the numerators to get an easy answer if the bottoms are not the same. Okay, what you have to do is convert both fractions to a different one such that they both, the new fractions, they agree on the denominator. So in this example, I would rewrite the 2 as 3/6, and I'd rewrite the 1/3 as 2/6, and lo and behold, now I can add them. Okay, how did I know to use the 6? Well, the 6 is the least common multiple of 2 and 3. That was one of the earliest examples that we did. Okay, and now you know how to find least common multiples. Therefore, you know how to find least common denominators, which are least common multiples.